Hi, this is Dr. Schulman. So this is another one of the assessments that you have an option to try. So this one's actually based on my own dissertation. You can look me up on Google Scholar for chronological mathematics and math identity if you'd like, but it's like my 250-page dissertation. So here's a little breakdown of that. But what is chronological multicultural mathematics, CMM, I came up with? It's basically using the past, present, and future to teach math. So this is how we can add context through the use of the history to help build students' identity. So I'm going to share my screen and I'll tell you a little bit more about it. So if you want to try this one, we can go into this piece, which is we're up to chronological mathematics assessment. And I'll just open it so I can talk about it. And I could read this whole thing, but basically, this is kind of how I feel like math should be taught the best, just in my own view, after trying and failing many, many times. Actually, when I was first doing it, and I could probably, if I have the link to something, so there's a link to my whole dissertation here. But I want to show you just a little note piece. Let me see if I can find something real fast before we jump into it. Let's do STEM integration, right? Yeah, okay, cool. So I'll tell you a little bit about how I got into this or how I came up with this idea. Did I have my own research in this one? Yeah, okay. So uh, these are two types of teaching of maths. Um, MHT or historical math teaching, and then multicultural relevant teaching. So when I first came up with this idea years ago, I thought relevant teaching was the best. I thought this is the best way to get students interested in mathematics. Relevant teaching is like put their names in it, put their jobs in it, put their sports in it. Use stuff that's related to them, put in their holidays, let the interest guide their instruction. And I was going to compare it to another idea that I had that I thought could be useful called historical teaching. And this was interdisciplinary. So I wanted to have reading, writing, and math, hands-on experiments, use role models from the past and the present, and current news articles. But to me, historical teaching was basically who made the math, why'd they make it, why was it useful, who's making the math now, who's using it now, and how can we help students in the future. But at the time, my historical teaching of the math was just about the past. When I first ran my first study, it was just like, so this is what my first study looked like, actually. So these are the results, but I did a Title I high school. I got to teach pretty much what I wanted because I had such high test scores somehow. But basically, I treated a class with just multicultural. This was for ACT preparation. So one, I did relevant teaching. That was like jobs, sports scores, all of that for every introduction. And then they took the same ACT practice test at the end. Now, traditional teaching, I would not put their names in it. I would just basically just do examples, straight examples all day long, like 3x squared minus 5x plus 2 equals 30, right? Whatever it was, just completely decontextualized traditional teaching. That was it. Just numbers, formulas, express, simplify. Then I had historical teaching. Now, the historical teaching at the time, I didn't have it built into what it is now, but it was just teaching about the past and who made the math and why, and that was the intro. So we had crazy discussions about Pythagoras. For mode, I talked about the Peloponnesian War and how they figured out how many bricks they needed they walked around the outside their structure in ancient Greece to figure out how many bricks they needed for their structures. And they used that and built the ladders. And that actually helped them win the war to defend it because they were able to build the ladder so quick and they were all at the same time using the modus or the most. So that helped my students really remember. So I thought relevant teaching would be the best. It turns out it was the worst. I even varied the periods. So halfway through the year, I had a whole new group of students, and I put multicultural, historical. So like historical teaching at the end of the day instead of the beginning of the day. Traditional teaching one in the beginning, relevant one in the middle. So I swapped them all. These were the amount of students I had. So it's about half in each class. And this was their scores on the ACT. So I ran an ANOVA, and I found out that it was significant. And then I did a 2-key test to see which one was the most. And I saw the only main difference was historical teaching was better than relevant teaching. Traditional teaching was here in the middle, right? You can see 68 for relevant, 71 for traditional, 80 for historical, right? So you can see the significance here was only between these two. But it really got me thinking, okay, there's something with historical, and that helped me build this idea of chronological mathematics. So not just the past, but build in the present and the future all together. So that's what I wrote my dissertation on. So there's a little bit, and it was actually medium effective as well as significant, which I thought was great. Okay, so basically for chronological mathematics, like what do we have here? So we often see math in this decontextualized format. The language are devoid of meaning and application, and just strings of numbers and formulaic constructions, often accompanied by the word solve, simplify value to graph. So why do we do this, right? It seems that we want to rush it. We'd have too much to cover. So why teach about anything else? Why give them the context? So we're trying to cram all these standards in to get students ready for high stakes exams. But when we take away everything else, it's trying to learn a language without knowing what like all the letters, right? Or what the punctuation is, right? So I think that's really tough for mathematics. And I also think a big problem with decontextualized mathematics is that students don't know if they're right or wrong at the end, right? Students never realize if they're right or wrong at the end of these things. So I'm just trying to see if we have one that has the whole thing in the beginning. No, that's okay. I was just curious. Okay, so here's one of the things. Like students sometimes don't even know where the numbers come from, which is crazy. This is Al-Khwarizmi. You don't know that one had one angle, two has two angles, three has three angles, four has four angles. Like a lot of times they don't even know where the numbers are that they're getting it from. So why don't we start there? Why don't we start with why they made the numbers, right? Instead of just having this like huge set of things where students don't really have. I don't know why there's 3 of these. I'm gonna have to delete some of them. Sorry about that. I'm just seeing what's in here. Okay, it is what it is. These are just some people. Okay, so let's get into it. However, even if students are able to read, so a lot of students could just memorize it. Will they be able to do a novel problem without the setups or new situations? No. So if you're just teaching them, they don't really understand what they're doing through rote memorization. They need this deeper conceptual understanding. They really need to be able to really know what the symbols mean, why they're doing what they're doing, and have more context. So this whole idea of chronological mathematics or chronological multicultural mathematics that I came up with is just how can we make it more context heavy? So math knowledge during the formative years is usually a mile wide and each decontextualized. And I think that's why we have to teach exponents every year. I think that's why we still have to teach factoring over and over and over again, because students don't understand what they're doing or why they're doing it. They just memorize it and then forget it immediately. So another reason for decontextualized math is that we want to help our students succeed. We think it's too hard, so we're trying to strip things away to make it easier. So a lot of students have anxiety from poor past experiences, and we want to see the discipline as not too scary or not too hard. I'm going to pause this for a second. I got like 3 emails in a row. And we're back. Sorry. Some students are really struggling with my statistics scores. So yeah, I wanted to make sure I help them when I set up a time to help them. So here we go. Sharing it back. And so we often believe that further behind the standards for their age class and begin the process of stripping away components. So we were just trying to make it easier for them, right? We omit context, applications, and meanings, but does looking at a string of symbols and steps without background meaning make it easier for struggling students? I don't know. Mathematics is a complex language built by humans to make things easier to understand, whether it's to measure distances or build structure or understand phenomena. So without knowing who made it, why it was made, or knowing its use, the student can come to the end of the problem and not know if they're right or wrong or what the answer actually means. So I think estimation is so important for students. While it may seem easier to teach without history of its creation, application, and current uses, or look to future innovations, this decontextualized mathematics dehumanizes the discipline, diminishes students' ability to relate or identify with concepts, and create the connotation as math is cold, rational, remote, inaccessible to all except the few special minds. And that's no good. It should be available to everybody. So in other subjects, we always talk about like Newton, or we learn about the authors, we learn about the scientists. The only person we ever talk about is Pythagoras, but most people don't even talk about Pythagoras, they just say his name. So if we talk about who invented this technology, it's going to help students see themselves in these roles and build interest and engagement into underlying reasons for about the concepts. Even when we talk about Pythagoras, he never even had these variables when we created it. So we don't even know why he did what he did. We don't know why he sadly murdered people or why he was killed off at sea. You know, we don't know why all this crazy stuff about Pythagoras or how we came up with the theorem. So I think without the human connection, the students are shortchanged. Sharing mathematics, spent lifetimes to create formulas, like Archimedes. We got Maria Agnazzi, who did the first comprehensive textbook calculated. By 30, she gave lectures fluent in 7 languages by age 11. She's awesome. She also did the curve of Agnazzi, which if you want to know more about, I can tell you. Claimed to have half their life saved by learning the discovery of logarithms to map out the solar systems. This is when Briggs took a train visit to John Napier, which is a cool story that I mentioned earlier. Wrote formulas of pi and chart infinity as a clerk without a high school diploma due to difficulty with English. That's Ramanujan. Did not see the uses of his creation, the quaternion, but the math concept became the major proponent in robotics and other AI inventions after his death, and that was Sir William Hamilton. So even Hamilton, like all the stuff robotics, these quaternions, like didn't even have use, but now they are useful. So I think this can inspire students to achieve greatness and normalize their struggles. So, for example, solve for x has no situation or reason behind the linear equation, no visual representation of this negative vertical line. Many students may not know the Al-Khwarizmi, who explained these ideas to Europeans and was the first to use our numbers, the numbers we use. So knowledge in the base 10 systems that are generated from are based on the angles. So this is all about making context visualization and history to make a more enriching learning experience. So in an effort to make mathematics more comprehensible, to build a positive learner, I have created this chronological mathematics. It was originally called Chronological Multicultural Mathematics, CMM. I should probably write what it actually is. And this lens uses a past, present, and future approach to humanizing the teaching mathematics to build students' math identity. So to do this, the identity, I'm using 3 components: self-concept, the achievement and belief in the ability to see oneself as they can do math; value, the usability of the concepts and interests; the motivation and engagement. So this CMM idea is based on the past, learning about the creators of the concepts, how they were created; the present, the people and the jobs currently using it for role models; and the future and alternative uses of the concepts. So this idea is how I broke down the past, present, and future. So this is past, basically the historical contributions from different cultures. Present's really just current jobs that use it. And the future is like, how can we use it in different ways? How can we take something like factorization and use it in a different way for the future? So there's tons of articles, there's tons of things that show why the past is so useful, right? include information about cultures and using primary sources and interdisciplinary approach. So you do reading, writing, science, and history. So these historical components humanize the concept and foster motivation through lessening the abstract nature of math. So we could reference stories, motivate, develop positive attitudes. And these are all these books and research articles that say why it's useful. The interdisciplinary nature is the history, language, and experimentation. Past acts of humanization can create investment as they can relate to creators of concepts. In addition, primary sources can provide the actual historical references to make concepts seem more real and inspiring. So that's everything about the past. And if you want to learn more about it, these are some great articles. Now, the present, I think, is just how is it used today? So past is useful, but what jobs are currently using it? A lot of times I use ideas like nursing. You can see in my dissertation all of the actual elements that I used. I'll go down, I'll show you some of these. So some of these elements that I made as soon as it loads, because it's 200 pages. Just so you can see one of these that has past, present, and future all happening at the same time. It's all the way at the end in the appendices. It was a long writing process, not gonna lie. All right, I think we're at the end. All right, these are the interviews I did. Here we go. So this is their task for exponents. They learn about the history of exponents. They see current things with exponents, and they have to see it in different ways. Here's the percentage task. This is probability. They get to listen to the story of how probability first came, and then use current ways to figure out who's going to win the basketball championship, the NBA championship. The stats one, you're going to get to see yourself. This one, I think, my students rated this as the most effective one, so I've been using it ever since. Because it really goes through the history of statistics, and then it goes through them doing a lyrical analysis of their favorite song. And then we got Cartesian coordinates, where it talks about 3D printing, and they get to actually watch videos of where 3D printing is today. But first, they get to start with seeing about Descartes and learning about exactly how he came up with the X, Y, and Z axis. All right, so those are some basic ones. Oh, this one's for linear equations. Oh, I forgot I had to do ones for 2 different courses. There's one for linear equations, and one of my favorite ones was factoring. How do we make factoring useful for students? Because so many teachers told me this was the hardest thing for them to do. So they get to hear from an actual architect who wasn't the best at math, right? Listen to this oh my God, a podcast about it. Read through the interview, and they get a really hard factoring problem. So you are this guy. You got to design a walkway around a tennis court using the actual dimensions, and you have to solve it using different sorts of factoring, or it's kind of like a factoring problem. But they want the walkway to be the same width all the way around the tennis court to be aesthetically pleasing. So what's the width of the walkway? What materials would you make it out of? And there are other designs you could create, and what would they look like? So, and then, then I have some really challenging problems in there. Oh, and this is the one for nursing. So rational equations, like how can they be used currently in nursing? This is how long drugs stay in the bloodstream for nursing, and the rational formula to get there. So and then they actually get not just one for drugs in the body, but interior decorator, coding efficiency, and then a challenge. I always try to do challenge problems as well. So these were the actual chronological, multicultural ideas that I try to push into these classrooms of students. They were just of math classes that they originally were failing. So these were all students who had failed the course before, and then every person in the program except for one was able to pass with flying colors and change their view of mathematics by doing getting these sorts of experiences within their course. So that's just some more information about it. All right, and so the future one is really interesting. So the future one is how can students take the formulas and use it in different ways, right? That's what I did with like the 3D printing ideas, or like what are new things in the future. So it's critical thinking as well as if I called one CM, I should call them all CM. So the future can help students shape their discipline in their own language. So critical thinking. There's some really high levels of depth of knowledge when you actually have to create your own problems using mathematical modeling and innovations. All these future ideas are just really useful for students. I think I put some more in here towards the bottom. So here's what it is. This is how it can build it. So the past is really built on the self-concept. The present really shows the utility and value right now. And the future is like your future interest about ideas. So I think these are all really good points. But how can you use it, right? So whole idea is like getting students to really get into the mathematics. So in order to incorporate such an idea, the teacher must believe that the math identity is dynamic and can change, right? So past research has shown that math identity is changeable. So we can change how people feel about the subject as long as they have a good experience. So these are a bunch of articles where people's ideas were changed. There's these turning points and impactful moments that can shift their perceptions, and their overall narrative of it can change. So here's the activity. So below are the elements to craft your own activity that you can utilize to help build students' identity. Ensure that you reference some journals. So in this one, I actually want you to look up some journals to figure it out. This is a website that you can use to actually rate journals. So any article you might find, let's say it was from, I don't know, the Journal of Consumer Research, right? It will come up, journal, oh, I didn't do the whole thing. And it will tell you how good the articles are. You can tell by the how many times it's been cited, which is really interesting. And this level Q1 is the best, Q2 is really good, but you can just see how many times it's been cited over time. Just make sure it's a really good article. So Q1 is usually what you want to see, a Q1 or Q2. And so these are the elements that you want to see. And oh, and I have all the tests. So I have literally a link to all the tests that I made to kind of help you see some. So here's a link of all the tasks. I just should change the name. And I guess I just put them all together for you, which is really nice. Yeah, so we have all the different tasks you could look at. So how can you make your own, right? So the first one, what is chronological, multicultural mathematics, CMM? Explain your idea, the concept, describe its benefits or drawbacks. Like, do you think it's just way too much time? Do you think it's not worth it? Decide or develop your own definition for math identity and how you got the concept. Describe if you believe math identity can be changed, why or why not? If so, what are elements that you believe can develop or change an individual's math identity? So let's make an activity. So select a class or grade. Explain the specific standard. Explain the plan for implementing the learning activity. So your materials, student grouping, specifics, what you will be doing as educator, what will students be doing for the activity, what are misconceptions. So basically just your plan for the activity. Now, explain how you plan to assess your learning standard. So checking for understanding, formative assessment, will there be homework and exit ticket discussion? If so, how will it be explained? Will there be a graded activity itself? All right, so then you have to talk about it. So how are you going to use the past? So are you going to use a primary source of a proof or a tool? Are you going to let students build an astrolab? Like it, I had my students once build these launchers for rockets. They were altitude trackers. for them launching the rockets to see exactly how high they went in the air? Will you do an image or biography of a mathematician? Will you show videos of the past cultures? Will you show the origins of the math symbols? Are there hands-on material? So basically, this is all about the past. The next one is the present. So will you create an application for current situations? Will you reference current professions that use the content, like I did with nursing? Will you show jobs that use the content? Will you bring in a speaker or video conference? Will you use online math platforms to explain it? So are you going to use Desmos, Delta Math, GeoGebra, Mathagon? Like, are you going to use some really current technology, like whatever's happening right now? And then we don't need this. So now we have the future, right? This is really important. So are you doing open-ended tests? Are you showing multiple ways to solve it? Will you ask students to discern the applications in other fields? Are you going to use a modeling, eliciting activity? This is a great resource about what that means. And can you help to redefine your math classroom with the activity? So the last piece of this thing is the identity development, which I think is really important. So state the specific ways you believe that your activity can build positive and more developed math identity in students. So can this help their self-concept or belief they can achieve as a doer of mathematics? Explain how they can show value. How are you showing this is useful? How is the content useful outside of the classroom to build their math identity? And the last piece is just how can you help develop positive interest, engagement, and motivation? The final thing that you have to do is, what's your opinion on this approach? I made it up, right? So even though I was able to say that it worked across 2 classrooms for a group of students, doesn't mean it's the best. What's your feedback on it? Like, I will not take it to heart if you think there's a much better way. Maybe you're like, future, definitely not. Or like, students are too far into the future to be looking at things like the past, like who made the stuff, you know? Let me know what your thoughts are about it. What was it like to make the activity? What ways can you improve upon math identity development? So are there ways you can make your activity better? Did any of your thoughts about math history or progressive teaching change? Describe ways to improve the assessment. And if you were to create this for pre-service teachers, like if you were to make this to teach them about chronological multicultural mathematics, what would it look like? So that is everything about it. And I'm going to show you the rubric as well. And the rubric is 15 points. Usually it's 15 points. So the first piece is your intro. Do you have a good definition of chronological? I'll just make it all the same because it's the same dissertation. I just like to be very consistent. So clear and descriptive definitions of CMM and math identity, mostly clear. So the first one is just definitions. Does it make sense for you? Your activity, do you have good protocols? Do you have directions? Do you have standards? Do you have plans? Are you assessing it? Is it just a good lesson, right? For this one, for the math identity development, is there a detailed description of the ways that the activity actually makes students feel like they can do the math? Are you basically being like, I'm going to show this to make them feel like they can do the math? I'm going to show this so the content feels more useful. I'm going to do this so that it feels more valuable. The reflection, I think, is always the most important. So for the reflection, it's like, how can we make this better? What do you like about this approach? What do you think you don't like about this approach? And is it clear and formatted? Does it have to be APA? No, I'd like it to be APA in case you ever want to publish something in your future. But are your sections clear? So this was my approach, chronological multicultural mathematics. If you've done this one, let me know what you think about it. Do you think it's useful? Do you think it's a good approach? I think it might be a new way to teach the topic. So I hope you found this interesting and reach out if you have questions.